Let's look at this problem. Compute 1 plus 3 plus 5 plus dot 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 plus 97 plus 99. So this problem asks you to sum up all the odd integers from 1 to 99. So how we do it? There are several ways of doing it. The first way is the following. Let's denote the sum as S. So S equals 1 plus 3 plus 5 plus 97 and plus 99. We observe that if you pair the first number and the last number, this is a 100. And then the second number with the second last number is also 100. And 5 to the third last number, which is 95, is also 100. And you see that this pairing can go on until it meets in the middle. Where is the middle? The middle is going to be 49 plus 51. You can verify this by seeing that the middle will be meet, the number which from the left is increasing by every time by 2, and the right is decreasing by 2. So where it meets at 49 and 51. So now the question is, we have a lot of pairs of 100, but how many pairs? So how many pairs? Of 100. Now again, for this, you can think about really several ways. One way is because the pairs are going to be complete. Your every number is going to be in one of the pairs. So for that, as long as we know how many numbers in this 1, 3, 5, all the way to 99, we know the total number of pairs is going to be the total number of numbers divided by 2. So how many numbers from 1, 3, 5, all the way to 99? This number is going to be the total number of odd numbers from 1 to 100. The total number of odd numbers. And you know that the number of odd numbers is going to be the same as the number of even numbers. Which the numbers are 2. So you kind of establish this 1, 3, 97, 99. You can establish kind of a mapping to 4, this 97, 98, and 99 to 100. So you see the number of odd numbers and the number of even numbers are exactly going to be the same. They can establish this so-called one-to-one mapping. And if that's the case, totally there are 100 numbers. So the total number of odd numbers is 50, and total number of even numbers is also 50. So how many pairs of 100 here? Because the total number of odd number is 50, so there will be 25 pairs of 100. So we know that the total sum, S, is going to equal 25 times 100. Because there are 25 pairs of 100 equals 2500. So this is the first way of solving this sum of all the odd integers from 1 to 99. The second way I like is just try to see a pattern. Let's see, instead of calculating 1 plus 3 plus all the way to 99, let's just to see the pattern of adding fewer terms in the sequence. What is 1 plus 3? You see 1 plus 3 equals 4 equals 2 squared. 1 plus 3 plus 5. This is going to be equal 9 equals 3 squared. What is 1 plus 3 plus 5 plus 7? That's going to be, this is 9. 9 plus 7 is going to be 16 equals 4 squared. Aha! You see that when I'm adding the first few terms, plus 9 equals 16 plus 9 equals 25 equals 5 squared. When I'm adding the first few terms, it's going to be a square number, right? And what is that square number? The square number, 2, is basically kind of correspond to 3 by 3 plus 1 divided by 2 equals a 2. And that's the 2 square. The 3 square, 1 plus 3 plus 5, 2, 3 square. 3 equals 5 plus 1 divided by 2. So it's like if you have 3 terms, it's 3 square. If you have 4 terms, it's 4 square. If you have 5 terms, it's 5 square. So you can conjecture, you can guess that if you do this, 1 plus 3 plus 5 plus 7 plus 97 plus 99 is going to be equal, the total number of terms here, let's call it k, is going to equal k squared. And from this argument here, how many terms that between 1, 3, all the way to 99, in terms of the total number of odd numbers, is 50. So we know that this equals 50 squared. So this is a second way of observing a pattern. And from the pattern, you can guess the answer. Now, this is not completely rigorous. And the rigorous way is still going to be doing sums like this. And I'm going to talk about a third way, which I guess I like the most because it actually requires no words. So stop for a moment. Let's copy the graph over. So here, I'm going to show you a way of using a picture to prove this 1 plus 3 plus 5 plus all the way to 97 and 99. This is going to equal 50 squared. And I'm going to prove by showing the following. 1 plus 3 plus 5 plus all the way to 11 is going to equal 6 squared. Okay, and the generalization from this to this is just going to increase the figure bigger. But let's consider the following figure, this figure, in the center. I'm showing a figure of a square figure with 6 dots in every row, and there are 6 rows. So total number of those dots is 6 times 6. Number of dots here equals 6 times 6 equals 6 squared. Okay, so this is one way of counting the number of dots, right? Each row has 6 and then 6 rows. Total number of dots is 6 squared. The second way I'm going to counting, I'm going to look at this kind of triangle shape. So first I'm looking at this one. I'm going to count this one, and then I'm counting this one, this L shape, and then I'm counting this L shape. So the first little square, there's 1 dot. This L shape has 3 dots. And this L shape has 5 dots. And this L shape is going to have 7 dots. This L shape, just mark it so that you can see clearly. This L shape has 9 dots. And the last L shape is having 11 dots. So what is the total number of dots in this figure? It's going to equal 1 plus 3 plus 5 plus 7 plus 9 plus 11. And obviously, this counts all the number of dots in this figure, which is, we know that it is 6 squared. So we just proved that 1 plus 3 plus 5 plus 7 plus 9 plus 11 equals 6 squared. Now how about the 7 by 7 square thing? we're just going to increase one of another L shape, which the total number of dots will be 13 because we effectively just increased a dots here. So you see from here to this one, we're increasing this one and this one, the number of dots. Compare this L shape with this L shape, we just increased by 2 dots. So by this, we know that 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 is going to equal 7 squared. And so on. We can easily see that 1 plus 3 plus 5, 7 plus all the way to 97 plus 99 will be equal the total number of dots in this square thing, which is going to be 50 squared. So this technique, well, if you can call this a technique, is kind of proof without words, just proof by pictures. And I like this a lot. So this is the end of this video about how you compute 1 plus 3 plus 5 plus all the way to 97, 99. That's going to equal a square number, a perfect square number. And we have shown 3 proofs. One is using the property of this is an arithmetic sequence, so you can do the pairing. All the pairs will be the same. The second proof is just observing a pattern. You do the first few terms and to see a pattern emerging out, and you can guess the result. And third proof is using this picture. Each proof has its own merit, and I hope you understand each of those approaches.